In this lecture, we're going to cover the projectile launcher gizmo. The projectile launcher gizmo allows you to launch objects or projectiles from a specific point in your world, with options to configure the properties such as size and speed, as well as implementing more custom launching mechanisms through scripting. This gizmo can be used to create a variety of interactive and immersive experiences, such as shooting or obstacle courses. So let's go over the projectile gizmo. To add it to your world, you go to Build and Gizmos, and then Projectile Launcher. We can drag and drop it into our world. And by default, you can see it has an arrow indicating where the projectiles will be ejected out of. We can rotate that slightly. And then we can have a look at the presets. So we've got spheres, we've got unlit spheres, which means the lighting in your scene will not contribute to the sphere color. We've got the rocket, a pistol, and a grenade. By default, when we start the world or start the world simulation, nothing will happen. And this is probably the first gizmo that we are covering that actually includes a level of scripting, because by default, there is no way to have these projectile launchers fire, for instance, on star or loop, as we have done before with visual effects and sound effects. So we will be introducing scripting. Before we go into the behaviors and the scripting part, I do want to mention a few limitations, such as the collision dissection is limited by the projectile speed, and then when a projectile, which is shot out from this launcher, collides with an entity, whether the projectile collision happens on the group or on the child depends on how the projectile is combined with other objects. Typically, a collection of entities is organized through a parent-child hierarchy that might affect how the collision occurs. So it may occur on the parent and will not be propagated down to its children. So just keep that in mind. And the number of active projectiles launched per launcher is limited. So there's only a certain amount you can shoot. Note that here in the behavior, we do have a projectile pool size. We can increase that to a larger size, but do know, obviously, the bigger the pool size, the more projectiles you have in your world, the bigger the impact on performance. Right here, let's have a look at the scripting side of the projectile launcher and see how we can actually launch it. Right, to set up a script for our projectile launcher, we are going to go and select the group in which the projectile launcher is contained in, or just the projectile launcher itself. Then we're going to click on attach a script, and then we can create a new script and call it whatever you like, such as launch projectile, right? Project. There we go. That is going to compile your script. We can see that TypeScript compilation will have started, and then it would have compiled. Your scripts would have been re-executed. We can also see this taking effect in the very top right. Whenever there's a recompilation of scripts, the changes are being resaved, and we'll also see this in the scripts tab. It will say when it's been last updated. If for some reason your scripts haven't recompiled correctly, you can go into scripts and then recompile those scripts again. Note that I do have a few additional scripts from other lectures. You may not see more of these, but that doesn't matter. The only one we're interested in is the one we just created under your name, and that should have compiled. Once you've created the script and we can see that it's attached to our gizmo, we can then open our script with an external editor. By default, Meta recommends something like Visual Studio Code, and that is my personal recommendation as well. But in theory, you can use any other IDE such as WebStorm or even Notepad, but I would advise against using Notepad because it doesn't have many of the nice features such as auto-completion and error detection that typical IDE such as VS Code would have. Right, so once you have your script, we can go ahead and select it, and then we can open an external editor. When we click on that, that should open our script in your default editor. And if you have VS Code installed, it should look something like this. We will have an import at the very top, which imports everything as Horizon from the Horizon Core module. Then we've got the definition for our class. The name of this may be different depending on what you call your script, but we can say that it extends the base Horizon component and its properties are a type of launch projectile. We've got props definition, which are the things that are sort of exposed in the properties panel that we've seen before. Again, it's empty by default. And we've got a basic start method. If you're coming from other engines, such as Godot or Unity or even Unreal, I'm pretty sure majority of them, if not all of them, have a similar life cycle for scripts. When scripts are initialized or started, they will have sort of a start method. They will also have this pause method, etc., etc. So this is very similar to what you might have. Note that I also have a few additional plugins or extensions in VS Code, which are throwing up a few warnings and errors, such as these squiggly lines. You may not see those, but these come from ESLint, which basically allows them to enforce a specific code style or format in my scripts. Now, this is more of advanced scripting, so we're not going to go over in detail, but that doesn't matter. Let me just format my script so it stops throwing these errors at me. There we go. Now I'm going to specify a void return if expected, and there we go. I believe we are all set up apart from possibly this. What is this? New line required at the end of the file. Perfect. So there we go. No more squiggly lines, no more errors. So let's see how we can actually launch our projectile launcher, or launch projectiles out of our projectile launcher, which is a mouthful to say. First, we need the definition or a reference to the projectile launcher itself. Note that because we attach the script as a child of the projectile launcher, so if I go back, we can see it is in fact attached to the projectile launcher. We can simply reference the entity that we attach the script onto with this .entity. And that gives us a reference to this gizmo that we have the script attached to. By default, this will be a component, and we need to cast it to the projectile launcher gizmo. So we're going to go as Horizon projectile launcher gizmo, and that will attempt to cast it to, as you guessed it, projectile launcher gizmo. Now, by default, we also need to assign not by default, but we also need to assign this to a variable. So let's call it projectile launcher gizmo is equivalent to this projectile launcher gizmo. Right, let's just indent that. Perfect. Now, it's still going to throw me a few warnings or errors. That does not matter. Oh no, then format our document, possibly. Format document. Oh, no, we can ignore that. Right, so we've got a reference to our projectile launcher gizmo because we've cast our entity that the script is attached on to the gizmo. And by casting it, we now have access to a lot more methods on that gizmo itself, such as launch. And then if we look at the definition by control clicking into launch, this gives us a nice detailed description of what the method actually does. It launches a projectile with the provided launch projectile options. And then if we hover over launch projectile options, we can see our choices between speed and the duration of the projectile. There is also the launch projectile method just above it, but we can see that it has been flagged as deprecated and that we should use the launch instead. So that is what we are going to use. Note that the question mark here denotes an optional attribute, which means we don't actually have to provide the options. So all we have to write is launch, and that is it. Now we can go ahead and save our script, and then if we go back into Horizon, there we are. We can see the script will recompile, and then because we've put it on star, the script, as soon as it's recompiled, it will actually launch or call the logic that we've written. Now what I can do is go over here and reset world simulation to force it to call the start method again. And there we go. We can see our projectile launches every time we start or stop and start the world. So when the scripts are initialized, and it's as easy as that. We can change it to something like a pistol. We're going to see that's what a pistol looks like. Same goes for the projectile preset for a grenade. Oh, there we go. Same goes for a sphere. There we go. We can see they're not currently influenced by gravity, so we can reduce it to like 0.3, but like 0.5 for the scale of the projectile. Let's aim it up a bit, and I'm going to restart. And there we go. We've got a projectile, maybe even more gravity. Can we do something like 6? Let's do something like 6. There we go. Maybe even something stronger than 9.81. Perfect. So we can see we've got our projectile launcher, and it's actually launching our projectiles. Pretty cool. Pretty cool. But of course, we don't want to have to restart our world every time the projectile launcher to fire the projectile launcher. So what we can do is actually wrap this method, this entire method, in an asynchronous function, which will keep calling this method every few seconds or milliseconds or whatever duration that we provide. So let's go ahead and do that. Again, we are not covering the entirety of the scripting in this lecture. We are simply focusing on making the launcher gizmo work. So let's go ahead and do that. To access our asynchronous methods, we're going to go and write this.async. And we can see we've got two options, set timeout and set interval. So timeout is another way to say set a delay before we call something. An interval means it will call this function or method that we provide at a given interval. We can see it takes a callback and a timeout. So we are going to go ahead and create a lambda method here. Basically means, we're going to create this sort of temporary method that has no clear definition. And then we are going to put our launch method in here. Then we're going to do a previous one. And then we need a delay here or the timeout here. Note that the timeout is in milliseconds. So what I'm going to do is set this to, let's do 5,000 milliseconds. Note that you don't have to provide an underscore. That's just optional. It makes it easy to read. Let's do 3 milliseconds, right? So when the start is going to be called, we are going to start an interval to call our launch method every 3,000 milliseconds or 3 seconds, right? When we save the script and rerun it, I realize I didn't switch, but there we go. We can have a look at the code again. This.async.setInterval. Then we're going to go ahead and wrap our method in here, create the lambda method, and then call the method every 3,000 milliseconds, right? So if we go back to Horizon, switch back to the Horizon view, we can see as soon as the script is recompiled, the projectile launcher is firing every 3 seconds like we told it to. Fantastic. That's pretty cool, isn't it? Right. Yeah, that works as it should. But what if you wanted to have different projectile launchers? What if you wanted to have, for instance, 2, and then maybe they fired at different intervals? What if you're creating an obstacle course, right? Well, we can go ahead and do that. And then what we can do is expose our delay that we specified here in props definition. Another name for props definition, or another way to look at it is what is exposed in the properties panel over here on the right. So just as we see the projectile preset, the speed, the player collision, all of these behavior properties, we can expose our script and have our properties exposed over here in the script itself. So let's go ahead and do that for the delay. So we can do interval in milliseconds, right? Then we're going to find the type as Horizon prop types dot number because it is a number, and then we can even provide the default to something like 5 seconds, right? Perfect. So we go ahead and save that, and then we jump back into the Horizon. Once the scripts recompile, we can go ahead and stop the world simulation just for now. Scripts were re-executed, perfect. Let's collapse that. So we've got 2 projectile launchers, and by default we can see that their speed is set to 5,000, right? Perfect. So we can see it has exposed our prop property over here. But that is not everything that we need to do. Now we actually need to assign that property to our interval, so it uses this value that we provide. But accessing properties isn't very performant, so what we're going to do is also create a class scoped variable, such as the interval, so private interval, we type the number, and then set it to 5,000 now. That doesn't matter. It's going to throw errors because it's never assigned, right? We can put it over here. So we're gonna call it interval milliseconds as well. It might be a bit confusing between the props definition and the class scoped variable, but that's okay. It's still throwing errors at us because it says it's never assigned. That's okay because we are actually gonna be assigning it. This starts from milliseconds, props. It's around milliseconds, right? We are reassigning it to our props variable. We can actually do that in pre-start, which is even better. Pre-start code base. So that's going to be called before start occurs. And we can go ahead and do that. Put it in here. Yes. I know. Throws warnings at me. Perfect. So in pre-start, which is called before start, we are going to assign our props definition value, which is interval milliseconds, into our class scoped variable, which is also called interval milliseconds. I mean, you can change this to whatever you like. By default, set to 5,000 as well, but again, we can change that to whatever we like. And then we're going to make use of this variable inside of our interval method or interval function. The reason we cache it is for performance. Each time we are accessing props like this, there is a bridge call happening between the client and the server. It has to go through a lot more steps basically to get that value that you've assigned. But if we cache it to a class scoped variable, that means we won't have to do all those bridge calls every single time we want to get that value. And that's going to be happening every few seconds or however long we set it. All right, let's go ahead and save that. And then let's jump back into Horizon. You can see our script again. And once again, I'm going to recompile. And then we can actually make use of this exposed property. So let's set this to 8,000. And let's set this one to 3,000, right? Oh, the hashtag by accident. Right, so the one on the right will fire every second, the one on the left will fire every 3 seconds. So let's go ahead and enable world simulation and see how that looks. So there you go, for every 3, if this one fires, one of these is going to fire. And there you go. That's how you get a interval working with different timings for your projectile launchers. Again, there's a lot more to cover, such as what happens when these projectiles hit an object or a player. How do we register those events? But we will be covering that in the scripting section. For now, we are just interested in how to invoke the projectile launcher and how to make it actually launch our projectiles. So yeah, there you go. That is everything there is to cover for this lecture. I realize there's been a lot and we just briefly introduced scripting. So don't worry if you feel a bit overwhelmed regarding scripting, because there's a whole separate section on scripting. And this just covered the very basics of it for what we needed. So yeah, best of luck with the projectile launcher.